So today we do word problems. So question number one, or example number one. A 16-foot ladder, propped. When you prop something, you basically position it or put it against something else. So it's propped against a wall. It makes an angle of 35 degrees with the wall. Okay? So you know how long the ladder is, and you know what degree, or sorry, what angle in degrees it makes with the wall. The question is exactly how far in feet, because this is the same thing in feet as well. In feet is the top of the ladder from the floor. So basically, it's something like this, everyone. Put this here. Okay, you can imagine it. We're going to sketch a diagram. Every single time we do a trig problem, we sketch a diagram. So imagine this. Oops. So imagine this to be the building, everyone. And we take a ladder. So the ladder, for example, could be the ladder could be this. So basically, so hopefully everyone can see. So basically, that's the problem, right? Building, ladder, and the question is, so the question is telling you how many pieces of information, how many numbers are in the problem. 2. It tells you how long this one is. Now, we hope that the building is built exactly at what degree? No, the building itself is built at, I'm hoping that when you build a building, you don't build it what? Tilted. Like when you actually go outside the school and you measure the angle between the grass and the brick wall, you're hoping that it's what? As 90 as possible. So we're going to assume that this angle right here, this perfect corner is 90. So where is the 35 degrees? Is it the top one or the bottom one? What does it say? According to the question. Exactly. It says it makes a 35 degree with the what? With the what? With the wall. Obviously, this is the ground. This is the wall. So basically, the 35 degrees, everyone, look at my finger. 35 degrees is right here. The question is asking for what? Is it asking for an angle or a distance? Just look at the question. Just look at the last sentence. What is it asking for? Is it, yes, Patrick? It's asking for a distance. By the way, could it ask for this angle? By the way, how easy is it to find this angle? Think about it. What kind of a triangle do you always have in this unit? Right triangle. We already know one angle is by default what? 90 degrees. We know this angle is how much? 35. How easy is it to find this angle? What do you just do? That was basically your first quiz. If you know two angles, how do you find the third one? You know two angles, huh? You well, but you don't add them together. You only know two. So what do? You add these two and you subtract from how much? 180. So if you actually do that, this will come out to be 55 degrees. So 55 plus 35 plus 90 is what? Is 180. However, it's not asking for the angle. It's asking for what? As Patrick said, distance. How far is it? How far is it from what? From here. By the way, why is it important when you use ladders kind of to know this distance? What's going to happen to the ladder if I push it? By the way, is the ladder still good so far? Is it stable if I push it towards the wall? Yeah. How about if I push it out? Eventually, it's going to hit a point where what happens? What do you mean? So why? Why do you think it's going to fall? By the way, why do you think it's going to fall? It's not a math question. Related to it, it's not a math question. It's more of a physics question. What's stopping anything from falling or from sliding? But what's the kind of things that stops you when you slide on ice? Say it? Friction, exactly. So far, friction is what? Is big enough to what? To make sure that this one does not what? Slide. However, at some point, what's going to happen? Friction is not going to be what? As big as needed, which means what's going to happen? It's going to slide. So every ladder has what? Has come some kind of a range up to which if you exceed it, what's going to happen? It's going to slide. Exactly. I do want to go there because then, by the way, and if you're on it, it's going to what? Slide faster, right? Because you're pushing harder into the ground. Okay, so that's why it's important to know these things. Perfect. Okay, so now let's take this and what? Quickly sketch it in here. Everyone, sketches are meant to be basic, simple, not complicated pictures like a painting. Just be simple. Okay. So here's usually how I sketch this problem. So, by the way, do I expect you to sketch a 3D or a 2D? Yeah, never sketch a three-dimensional one. Way too complicated, and honestly, it does not add anything to your understanding. So, first of all, everyone, let's choose red. So you sketch the what? What is this? This is the ground. Okay. Now I can either put the wall here and the ladder here, or vice versa. Doesn't matter. It's completely random. So I'm gonna say that the again, my solution that I will post might look slightly different, but it's the same idea. So everyone, here is the wall. And whenever I sketch a wall, I always do it this way. I kind of like make it look like bricks. Go ahead, come on. So bricks, bricks, bricks. And how do bricks? Bricks are laid in what? In a staggering style. You never lay bricks this way. Nope. You lay them zigzag. So like this. There you go. That's a perfect wall. Okay. Now I have to sketch the ladder. Obviously, the ladder has to look like a line like this. However, I'm not going to sketch a line. I'm going to sketch a couple of lines. I like to make it look like a ladder. And ladders basically are like this. Okay. Perfect. Now let's put some numbers in. What number could I put in first? 90. Perfect. Nice. I did not. I expected people to say 16 or 35. Nice. Always put the 90 first to indicate that you are in the kingdom of trigonometry. You are doing right triangle. Okay. What else? Hmm? Where? On the top. Thank you. So everyone, right here, you just write 35 degrees. 35 degrees. Do you have to show me that this is 55? Or is it just enough to put one acute angle in a triangle? What do you think? Do you have to show me all three angles in a right triangle? No, you already showed me the 90. So you either showed me what the one of the other acute or the other one. That's fine. Okay, any other numbers? Any other information about this system? No, no, numbers. No, 55 degrees. That is extra information that I really don't need. Come on, what's the only number mentioned? Yes, Eba? Yeah, the 16 feet exactly. Where would you put that? Would you put it here? Is that 16 feet? No, that's an angle. That's 55 degrees. So where would you put it? Exactly. Where? Always somewhere in the middle. So I'm going to put it like this, 16 feet. Okay? All right. Great. We have a triangle. Should we label A, B, C? What do you think? Are we doing similar triangles or are we doing trigonometry? Because it depends. In similar triangles, like your first quiz, how did you label? In A, B, C, capital A, capital B, capital C. How do you always label in trigonometry? Remember all what we did yesterday. Everything we did yesterday. Come on, people. Say again. That's C squared equals A squared plus B squared. That's Pythagorean theorem, which technically you can apply here, but we don't need it. Opposite, hypotenuse, and adjacent. Okay, which one is the hypotenuse in this triangle? Right there. Exactly, the longest one or the one opposite from the 90 degrees. So this is hype. Go ahead, hype. So can someone tell me now which one is opposite to the 35 degrees? Is it the wall distance or the ground distance? The ground distance. If you stand here or if you are here and you walk away from this angle, you're going to hit this side right here. Perfect. So you write OPP. And obviously, somewhere in here, like in the middle, you write A, D, J. Which one does the question want us to find? Does it want us to find the OPP or the ADJ? How many people say OPP? You're right, because the question is saying how far. Oh, hold on. Read the question. How far is the top of the ladder from the floor? Top of the ladder from the floor. So what is it asking? Adjacent. So in a way, how high is a window that you can reach? How high is this window? Imagine there's a window you're trying to clean. If you prop it 35 degrees here, 55 degrees here, and you have 16 feet length of a ladder, how high of a window could you reach? So this one is the one This one is the one that we need. So I'm going to put a question mark on it. Good. Put a question mark on the diagram. Never put a question mark in the math. Okay. So my question now is, which two sides am I trying to relate? Which side do I know? Just which side do you know? You know the hypotenuse. Which side are you trying to find? Adjacent. So you always say this. We want to relate hypotenuse and adjacent. Go ahead. We relate. By the way, that's going to be the first statement I write in every trig problem. We relate hype and adjacent. So the question now is, which one of the sine, cosine, and tan, or tan, I should say, or tan, relates hype and adjacent? Only one of them works. The other two, we have nothing to do with. So you're saying, how many people say cosine? Absolutely, because it's so, ka, toa. Ka relate what? It's cosine, adjacent, and hypotenuse. Perfect. So you say what? We use cosine. We use COS. Okay. How do you actually start the math now? You have to say, just like the problem we said yesterday, cosine, so COS, of which angle? Which angle of those do you really need to use? Exactly. You never use the 90. You never use the 90. You just want it to be there, but you never use it. You can either use this one or this one. Well, we already have decided. Oh, sorry. What do you always decide when you know which angle you want to use? You put a what? You put a circle on. Sorry. So everyone, just put a circle on here. Great. Okay. So cosine of 35 degrees equals, as you said, adjacent over what? Hypotenuse. All right. How am I going to find cosine of 35 degrees? Do you think I know it by heart? Or do I need to use something? What do I need to use? A calculator, exactly. So everyone, again, remember that your calculator should be what? Should be set on what mode? Degree mode. Okay. So again, what do I do first? Do I tell it what to do and then punch in the number? Or do I do the other way? Again, this is my machine. Your machine could be different. I put the number first. That's how my machine works here. So I'm going to put 35 degrees. And then I'm going to go to trig and hit which one of these? Which one? Oh, do I need to push second? When is the only time that you need to hit second or shift? Only in one case. If you're trying to find what? When you're trying to find the angle. Do we already know the angles? Yes, we know all of them. We know 90, we know 35, we know 55. So you know what? We do not need to what? Hit second. I just hit whatever I need to use. Which one of these three am I going to use? Cosine. So am I expecting a small or a long number? Long number. And how many digits do we take? 4 decimal digits. All right. So how would this one, oops, sorry, would it stay as 8191 or will it go up to 8192? 8192 because the 5 will bump up the 1. Great. So 0.8192 equals. Now, which one of those two do I know? Which one of those two do I know? Adjacent or hypotenuse? Great. Put the 16 where it is. 16 is here. Now, what should I put instead of adjacent? Could I put a question mark? Never put a question mark in math. Put it on the diagram, but never in the equation. What could I say? Yes. I could put X. Could I keep calling it edge the whole time? Yeah. Could I switch it to small a if I want? Yes. My two preferences are either, as Jane said, X or keep calling it what? Edge. You know what? Let's keep calling it edge. It's a short word that it's not a big problem to actually keep calling it. So A, D, J. All right. Whenever you have something like this in all the math courses you ever take, what do you do next? There's only one thing you can do. Crisscross or cross multiply. But then you have to show me what before you do that. The one. Where? Under. Exactly. You have to make them both look like legit 100% fractions. So you put the 1. Okay. What multiplies what if you cross multiply? And then 16 hits what? This one. And what's the good news? Adjacent, which I want to find, multiplies what? 1. What's anything multiplies 1? Is it the 1 or the anything? It's the anything. Perfect. Which is good news for us. So it's what? A, D, J. Do you have to show me in your written part? Do you have to show me A, D, J times 1? Nope. We know that anything times 1 is going to result in the thing itself. So you're more than welcome to just say ADJ. Now I need 16 times 0.8192. All right, equals, let's see. Yeah, let's just check. 16 times 0.8192. Ready? All right, bunch of numbers. Did I say how many numbers to round to? Does the question say so? No, it doesn't. Again, my apologies. On a test or a quiz, I'll never make that mistake. Always remember to. And if I forget on a test or a quiz, please let me know, because I need to make sure everyone does not get stressed out on, oh, how many numbers does he want me to keep? Well, you know what? Let's just look at this. How many numbers, sorry, how many decimals am I showing here? I'm showing a whole number, which means what? No decimals. So you have a choice. You can call this, you can say, since this is a length, since this is the length of this one, and apparently lengths are rounded to no decimals, you can round this to what? No decimal, which means what? Let's just enlarge it. So you basically cut it right here. Would this be 13 or 14? Yeah, it's way closer to 13 than 14. It's barely even over the half. It's not even, sorry, it's not even above a half. So you can say what? 13 meters. How about if you want to go to 1 decimal? It would be what? 13.1, because the 0 is not going to what? Bump. How about if you want to go to 2 decimals? Exactly, 13.11, because the 7 will bump up, and so on. You know what? Let's write both answers, 13 or 13.1 meters, okay? So 13 or 13.1 meters. Actually, let me just write it here. Oh, sorry, feet, my bad. I guess I'm so used to meters from other problems in physics. Feet or, thank you. Done. That's it. By the way, what's the only kind of like logical check that this answer does make sense? Again, I'll give you a hint. We have a right triangle. We have a right triangle. Again, if you're ever not sure about the math, just redo the math again. But at least, what could you make you feel okay about that number? What's your hypotenuse? How long is it? 16. The hypotenuse is always the what? The longest one. And because this is 35 and this is what? 55. This one is shorter than what? But this one is also shorter than what? Perfect. 13 or 13.1 is less than what? 16. That's your best bet. At least your answer makes what? Logical sense. As far as numerical sense, if you're not sure, I really have no other way. Go ahead. To actually what? Except redo the math, cross, and just check here. By the way, again, reminder everyone, what is one common mistake that people do, not because of the math, but because their calculator in the angle, it's not set in degree mode, it's set in what? What's the other bad mode? Like bad way to measure angles that you're not supposed to use. What's it called? What's up? RAD. Yeah, RAD. If you ever see your machine say R, capital R, or RAD, make sure you switch it to what? Capital D for or degrees. Never have it on any other mode. By the way, there's another setting called, again, advanced math. You have to know it. It's actually called GRAD, grad. Again, if you see G or R, never use them. You have got to use capital D for degrees. Okay? All right. Perfect. And that's a very typical what? Word problem in trigonometry. Okay? Let's do the second one. Okay? By the way, I noticed something in some of your diagrams. Everyone listen up. I'm noticing that people, whenever they have ground, look, everyone, check this out. Whenever I give you a box to sketch and the ground is supposed to be sketched in the diagram, many people put the ground where? exactly here. Is that wrong? It's not. But you don't have to always think that the edges of the what? The edges of the box are the ground or the wall and so on. No, no, these are just the boundary of the what? Of the sketching space. So I would really encourage you to what? To never use this edge as the what? As the floor or the ground. Another reason is if you use it here, you might not have what? Enough space to write, certain labels, right? Like angles or, sorry, not angles, lengths or symbols and so on. Always make sure that you sketch everything within the space itself. Okay? Very important. Again, I'm not going to take marks off if you do that. Math is math. But always make sure you don't always think that that's the floor, that's the wall. No, that's just a sketching space. Put everything inside. Okay, let's look at the second one. Again, by the way, ladder problems are so common in what? In trigonometry. Yeah, because every single time you put a ladder against a wall, you right there, you make a 90-degree triangle, which means trigonometry and Pythagorean sometimes need to be used. Okay, so you place another ladder, but this time, how long is the ladder? How long is the ladder itself? 10 meters. Leaning, so standing, sorry, not standing, supported on a wall. The ladder makes an angle of 70 degrees, but with the what? With the ground now. Okay, so is it going to be a similar, not similar triangle, a similar diagram to the first one? Yeah, but instead of a top angle, I'm going to put what? Bottom angle. Okay, the first question is, can you reach a window that is exactly 7.5 meters above the ground? Interesting. That's what we call a checking question. It's not asking you to find something. It's asking you what? To check if you can, or if that number actually what is legit within the diagram. Okay, regardless, we have to sketch. Let's do that. So again, go ahead and sketch almost the exact same diagram as before. So we have the ground. We have the straight up wall with bricks, even if it has no bricks. Good. Skip, 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 and then go back, back, back. There we go. And then my ladder. Okay, that was easy enough. What do I do next? Label. Where's my hypotenuse? Oh, sorry, but before label, put numbers. Uh, how long is the ladder? 10. Go ahead and put 10. 10 meters. Where is this? Oh, 90 degrees, of course, without question. Which angle is 70? This or that? Yeah, I mean, look at the triangle. Obviously, I made this angle much more open than this one. So this has to be 70, which makes sense. Okay. So go ahead and put 70 here, 70 degrees, and circle it. Okay. Where's my opposite? Sorry, hypotenuse. 10. Thank you. So go ahead, 10. H, Y, P. Okay. Where is my opposite to the 70? Is it the ground or the wall? Yes, you see, when you look at different angle, things switch, right? Before, the top one was our interesting angle, so the opposite was down there. Here, our angle of interest is here. So that means my opposite is the vertical wall. Again, that's why it's important to know which angle you look at, because everything depends on that. So go ahead and put OPP. And obviously, no chance here except for this to be ADJ. Okay? Now, everyone, the question is asking me, everyone, put that, do that, and pencils down. The question is asking me, can you reach a window that's exactly 7.5 meters above the floor? No more, no less. So which distance do they technically need me to find? The bottom or the top? They want you to find the what? The opposite. Once you find it, what are you gonna do? You're gonna compare it to what? You're gonna compare it to 7.5. If it exactly is 7.5 within rounding, then what? Is the question saying yes? Yes, I can reach that window to clean it. Whether you're above or below, the answer then is what? No. You see what I mean? So it's not saying, what if you got a distance of 10 meters? Can you then reach a window? Apparently, no, because you brought it way too what? Way too what? Way too low or way too high? Way too high. So what do you need to do? Lower it. And that's what the question is what is here. Manel, can you read part B of the question? To part A was no. Uh-huh. Exactly. Obviously, everyone, if you reach lower, what does this angle need to be? Lower or higher? No. If you reach lower than 7.5, you need to make it what? More than 70 degrees. What if you reached and overshot the window? Then you need what? To go. So one question is asking you to find the length, and then the other question is asking you to find the what? The what? The angle. If the first one doesn't work. If the first one doesn't work. By the way, I made it so it doesn't work. So we have how many parts to the question? 2. All right. So let's start. We need to find opposite now. We need now to find opposite. Now, which one of those 3 sides do we know? Hype. Great. So we know hype. And which one of those 3 do we need to find to compare it to this guy? OPP. I need to compare 7.5 to the what? To the OPP, because the OPP is the height of the window. So I'm going to say what? We relate what and what? Hype. And you always relate one thing you know to one thing you want to find. Go. All right. So we relate. We relate hype. Doesn't matter which one you write first, as long as you write both. Hype and what? Hype and O. Which one relates hype and O? Only one. Not only one. Which one? Sine, because it's so. Sine equals opposite over hypotenuse. Perfect. So we use sine. We use S-I-N. Not sin, sine. Okay. Do we still do it the exact same way as the first problem? Literally the exact same amount of work. Okay. So sine of which angle? Yeah, whichever one we circle, we keep using. 70 degrees equals. Is it hype over op or op over hype? By the way, a common mistake is people use the correct ratio, like the correct 2 things, but what? They put them in the wrong spots. So which one is it? Is it O over H or H over O? Yes, it's not SHO, it's SO. SOH. O over H. Perfect. It's a common mistake that people flip them and then everything is completely wrong. All right. Now, what's sine of 70? I don't know. I memorized, by the way, in math, they make you memorize special angles like 30, 45, 60, and the rest, you just use calculators for it. So let's use it. What do we have here? Clear. 70. Do I use second? No, I know the angle. That's good. I just need to find its sine. Boom. So what would this be to 4 digits? 9397. Yeah, 939. The 9 after the 6 will bump it to a 7. So 9.9397. By the way, just so you know, everyone, if you in your solution used 0.9396, so like you cut without rounding, I'm not going to take marks off. Okay? I am not going, because again, am I teaching rounding or trigonometry? Officially, this is a trigonometry. These little things, I'll keep commenting. I only take marks of rounding when you get to the what? To the final answer. Final answer for me is where rounding matters, okay? Although intermediate steps still count, but for no marks, okay? Other teachers are different. They probably would take marks off because rounding is important and needs to be done properly every step. Okay, equals. Do I know my op or am I trying to find it? Great. So you can call it X. You can keep calling it OPP. I'll keep calling it OPP. Over. What's my height? 10. What's my good friend? First number. Which first? Are you talking about this one? Sure. Not following. Oh yeah. Sorry. You mean technically the final answer for this stage? Yes. 1, cross. What's the good news again? OPP multiplies what? By the way, It doesn't always happen that the thing you're trying to find multiplies 1. You're going to find out in some problems, okay? So OPP equals, what's any number times 10 if it has a decimal point? What do you do with the decimal point? Do you move it less or more? Yeah, the number gets bigger 10 times. So basically this becomes 9 point, whatever, a bunch of things. 9.397 in what? In meters. Okay, whether you round it or not, is that equal to 7.5? So what does that mean? If you make the ladder go at 70 degrees and it's 10 meters long, did you make it to a window that is same height, lower height, or much higher height? You actually reached almost. What's the difference between 9 point? By the way, this is very close to 9 point what? 4, 9.4. And what's the window you're trying to get to? 7. So it's almost what? 2 meters above, which means what? Do you need to raise it higher or drop it lower? Great. So we have to say first, no. So the answer is no. You reached higher than 7.5 meters. Okay, we need the lower angle. We need a lower angle. Okay, that is absolutely fine, no problem. So what am I going to do now? Okay, everyone. Technically, I have to resketch the whole thing again. But this time, should I keep this as 70 or make it unknown? Exactly. Now I'm trying to find this one. So what things do I know now? I still know that the ladder is how long? And now I know one thing. How high is the window that needs to be cleaned? You see now what we know? We used to know an angle and a height. Now I know what? A height and a what? And I'm trying to find the what? I'm trying to find the angle. By the way, could I find the adjacent? Yeah, I could say this is my height, this is my op, and this is my adjacent, but that would not be trigonometry. That would be what? Pythagorean theorem. Maybe the question sometimes would ask for that. That is fine. By the way, you should know something now, everyone. I could give you a question, listen up, where you have to use what? Multiple things that you learn. You see what I mean? I could give you a right triangle where for some part of it you have to use what, for example? Sine, cosine, and tan. Or for some other part, you have to use what? What's the first thing we studied? Pythagorean. Yeah. Hey, a right triangle is a right triangle. It accepts two things. You have to decide what works at each stage. Okay. So now I'm gonna do what? Everyone, quickly. We're not gonna sketch the whole thing. Of course not. We are just gonna sketch a quick triangle. Everyone, go ahead. Just sketch the triangle. There we go. How long is this one? Still. By the way, this is the ladder. This is still the ladder. 10. Go ahead and put 10 on it. So 10 meters. How long is this one that you wanted to find? That one needs to be what? 7.5. This is, now everyone, from here to here is the distance from the floor to the window you're trying to clean. So go ahead and put 7.5 meters. And what are we trying to find? Not the length, the angle. Thank you. So by the way, go ahead and put a question mark here. Okay. Let's label. Where is my hypotenuse? Yeah, 10 meters. Go ahead. 10. Sorry, height. Where is my opposite to that green angle? Where's my opposite to the green angle? 7.5. Perfect. And this will be my adjacent. Okay. Do you think I should label my angle at least? Oops. Do you think I should label my angle? Yeah. When you want to find an angle, you have to call it a name. What name can you call it? But it has to be what? Small letters or capital letters? Remember, just like similar triangles, what did you call the angles? Corners are always given what? Capital letters. Sides are given what? Words like edge, hyphen, up. So what can we call this? Anything you want. X, capital X though. Capital A, let's call it capital A. So everyone go ahead and just put A here. Which two sides do I know? By the way, could I find the adjacent right now using Pythagorean theorem? And then it would be something like this. Look, everyone. Let me just remind you of what we did yesterday. Everyone. Oh, sorry. Actually, it's here. Everyone, check this out. If I found the third side, would it be like those? How many people agree that if I found the third side, it would be a question like those? If I found the third side, would it be a question just like this one? 100% yes. But that means I would still have to find the what? The what? The third side. Do you always need to find the third side? No, because a sine or a cosine or a tan will work for you. Let me show you what I mean. What do I know? Come on. What do I also know? I need to relate opposite and hypotenuse. Which one only relates opposite and hypotenuse? Sine. So we're going to start with the same thing. We relate OPP and hype, which means we use great. We relate op and hype. We use sine. And now what am I going to write, everyone? This is going to look like this now. Check this out. This is going to look like this. Exactly the same thing. Write the equation, find the decimal, and then what? Now you have to hit what on your calculator? You have to hit second or shift. Now you do it because you're trying to find the what? The angle. Perfect. So sine of A, because you don't know it yet, capital A please, equals opposite over height equals. How long is my opposite? 7.5, 7.5. And this one is 10. Hey, what's 7.5 divided by 10? It's like 7.5 times 10. But if you times, you move it here. If you divide, you move it where? Here. So what's 7.5 divided by 10? 0.75, yes. By the way, everyone, just so you know, never write this. I'm pretty sure some of you are used to this. How many people are used to writing it this way? Never do that. You want to piss off a math teacher? It doesn't take much to piss off math teachers. But you really want to annoy them, write things like that. You cannot just write a what? A decimal point. What has to be before the decimal point? There has to be a digit. And if there is no digit, if the number basically less than 1, you have got to show the 0. Please make sure you always do that, okay? Okay, all right. Now, is this my angle or the sine of my angle? It's the sine of just like this. This decimal is the sine of A. This decimal is the cosine of X. This decimal, 1.3333, is the tan of K. You're not done yet. You just need one more step. And what's that step? Doing the inverse or doing the backward. So you say angle A equals sine, and you show what here? What does second or shift show you? -1. Thank you. By the way, never put the -1 here, please. It's to the power of -1. -1 is basically kind of like a power or an exponent. And what do you put inside? Whatever number we have here, which came out to a clean 0.75. All right. Now I have to find the angle. All right. Clear. Okay. What do I do first? Put the what in? Thank you. Number 0.75. And then hit trigonometry and hit what? You have got to see the -1. You don't see it then, you're in trouble. Boom. And which one of those three do I choose? Yeah, whatever one we decided from the beginning. Are we ready? Okay, everyone, before we do it, are we expecting an angle bigger than 70 or smaller than 70? Because we need to reach a lower window. So whatever comes out has got to be less than 70. It's probably a lot less than 70. Oh, quite a lot. You had to bring it down over 20 degrees. Actually, to be exact, 21.5 degrees, something like that. Okay. What's the rounding situation? Okay, everyone, just so you know, most likely in math courses, listen up, most likely in math courses, in any math course you take, Usually degrees are round to a what? A whole degree. Grade 10, grade 11, grade 12. Honestly, I am not so sure why, but maybe because most of the time you're never given a degree in what? In decimals. You could be given in length in decimals, right? Like a 9.7 stick of wood, for example. No, degrees, you're always given 38 degrees, 21 degrees. You're never given a question with 21.3 degrees, okay? So that's why degrees are usually rounded to a whole number. What would this be? Hold on. What would this be to a whole number? Is this closer to 48 or did it make the cross to 49? It did go beyond the half, which means it is 49 degrees. So to rounding, you need to actually go 49 degrees. And that's, which makes perfect logical sense. You had to drop it low. Nice. Okay, everything makes sense. You have got to just do two things. Tell it to yourself as a story. Imagine yourself in the situation. And then a diagram would be super helpful. Okay, okay, everyone, last one. And by the way, this last one is actually a very common realistic application of what? Of trigonometry. Now, everyone, pencils down. How many people have seen laser pointers before? Yes. They, I mean, it's an amazing technology. 40 years ago, it was like Star Trek, imaginary science. Now you buy them at freaking dollar on. Okay. So I have one, but this one, I, I need batteries. Okay. I'll break it. How do they actually? How many people know what it's a degree? And it's called surveying. Does anyone know what a surveyor does? Surveyors. Okay, I'll give you a hint. Sometimes you see them outside. It looks like someone with a tripod and a camera. It's not a camera, but do you know what they're doing? Huh? Massah. Yeah, someone who actually takes what? What do you actually think they do? Looks like a tripod, legit tripod, and some device. It's not a camera. What do you think they're doing? Surveying. Because some of you might actually go into that. Surveying are people who actually what? Basically take measurements of land and building. Okay? The survey means what? When you survey, you look at big thing all at once. Okay? If I come in and I will say, I want to do a survey. What does survey mean? Survey mean ask you all just what? How many questions? One question. So I'm taking what? I'm taking a snapshot of all of you. So surveying. What do? They actually are trying to what? For example, estimate from the door of the school the height of the trees over there. What do they actually do? Everyone, look, check this out. They actually use trigonometry like this. They have a laser pointer. The difference, though, between their laser pointer and mine is that, look, my laser pointer, everyone, my laser pointer, if I had the batteries, if I click on it, what would you see if I click like this? What would you see on the ceiling? Yeah, by the way, most laser pointers are what color? Red, okay? You would see a red dot. That's it, we're done. Their laser pointer is different. Their laser pointer actually what? Shoots laser, and when something actually what? Look, blocks it, like if I was a surveyor, look, and I actually click, it would actually what? Not only send, but it's also gonna what? What's the opposite of send? Receive. Thank you, exactly. It would actually send and receive. So what they actually do, everyone look, let's say for example, okay, I want to estimate, I'm a surveyor, I'm standing right here, let's say 9 feet from the wall. I want to estimate the height of the wall. What they do is this. Look, everyone. They what? They shoot the laser pointer and they keep what? They keep doing what with it? They keep what? Come on. They keep increasing the angle. They keep going up, going up, going up. Now, if I just shoot like that, do you think I'm gonna clear the wall or is it gonna bounce back? Come on. If I just go like this, do you think the red dot would actually appear on the wall? Yeah. How about if I keep going up? What's gonna happen to the red dot if there was a red dot? Gonna keep what? Going up, going up. But at some point, what's going to happen? Imagine if there's no ceiling. Imagine if this was an open classroom, like an open box. At some point, would you be able to see the red dot? No. The machine then would tell you what? Stop. This angle is what we need. Do you see what I mean? That angle is related to the what? Is related to the height because it stopped what? It stopped receiving what? The what? The laser pointer being what? Blocked back. Do you see what I mean? So as long as it's blocked, it's got to receive it back and tell you, nope, you're still hitting the wall or hitting the tower or hitting the building. Keep going what? Keep going up and up and up. At some point, that laser is what gonna clear the building, right? When it clears it, it's got what? It's gonna give you a buzz. Yep. Yeah, go ahead. It's gonna give you a buzz saying what? Stop what? Stop increasing the angle. You just got what? The maximum angle to what? To perfectly know how high the tower is. Okay? By the way, what would be the other way to actually estimate how or know the height of anything? Physically, what? Do we have long enough measuring tapes? Do we have long enough measuring tape to actually, for example, measure the height of the CN tower? No. So what's the only way to actually measure its height? Literally this way. Keep angling the what? The laser pointer until it tells you, oh, that's it. Just stay right there. And here is your triangle. That's actually a very common, essential use of trigonometry. So let's look at this problem. From a point that is 4.5 meters away from a tower, which, by the way, is very close. Like if the wall of the tower is right there, everyone, eyes on me. If the tower is that way, how long is 4.5 meters? Yeah, tops. Just that. It takes you an angle of what? Who can read that word? Angle of what? Okay, everyone. When you look at something, you can either what? Look up or okay. When you look up, that means what? Are you low or high? Are you yourself? When you look up, you are what? You are low. That's why you have to look what? Come on, you have to look up. That's called an angle of what? Elevation. So imagine this. Imagine this to be angle 0, right? If I need to look at the tower, I'm going to have to look up. Okay? What if I'm actually what, for example, what if I am standing up and I want to look at Manel? Am I going to look up? I'm going to look what? Okay. What's the name of the angle when you look down? They have two names. They call it angle of what? Say again? Depression, because depression just means feeling low. So you went low. Or angle of declination or decline. Okay? So elevate or what? What was the other one? Kellen? Depression. But for depression, you have to be what? Lower or higher than the thing? Higher. There you go. Okay. So you are lower than the tower. That's why you elevate your sight. How much do you have to look up? How much? What is, by the way, does that make sense? Of course. Everyone, question for you. If I'm this far from if I'm this far from the wall and I want to see the top of the wall, do I have to look like that or do I just need to lift a little bit? Yeah. What if I get very close and I want to see the top of the wall? What do I need to do? A little bit or a lot? You see what I mean? The closer you get, what happens to your neck? Do you have to what? Tilt less or more? Which means your angle gets smaller or bigger? No, your angle from here, like the opening. Exactly, right? Because basically your what you call it? Your triangle's got to be very tall and thin, right? And that's why, how big is the angle? How big? 87 degrees is very close to what? Yeah, you're almost looking straight up. You're almost looking from here. You're almost looking what? Straight up. That's because you're very what? You're very close. You're only 4.5 meters from a tower. Towers are high, so you have to really look up. Okay. All right. So let's what? Sketch a triangle. Okay. What objects do we have to sketch? Come on. Everything is standing on the what? On the ground. Okay. We have to sketch a ground. Also, we have to sketch what? We have to sketch a what? A tower. How do you sketch a tower? Nothing. Just like a thin, like yeah, exactly. Like for example, like a thin needle. Okay, like the CN tower. And also, what do you have to sketch? Okay. You can sketch a person. Obviously, the person in comparison have to be very what? Yeah, exactly. So everyone, this is how I'm gonna do it. Here's the floor. Come on. Tower. I'm just gonna sketch something like this. Something that gets like this, and then I'm gonna sketch it like the CN tower. You know, they have the this, and they have the needle. Hey, that's a tower. Looks like a needle. Okay. Okay. Where are you standing? Well, obviously you're standing very what? But does your diagram have to be perfectly exact? No. And if you make it too close, you're not gonna have enough space in the triangle to put opposite angles. So everyone, exaggerate and put the point right here. So everyone, you are, as a person, you are right here. You don't have to sketch a person. You can just sketch a dot. And you are looking straight up. Straight up, straight up, straight up, straight up. There we go. Hello, right triangle. Okay, let's put some symbols on this. Well, obviously, the first symbol is the 90 degrees. We're hoping that the right here was 90 degrees. Okay, what other numbers do I know? Come on. Where's the 87? Is it here or here? By the way, the 80, the angle of elevation is the angle at your eye level. Where would that be? Exactly. It's the angle at the person. It's the angle that the person had to look up. So everyone go ahead and put 87 here. Okay, what's the other only number that we can put here? How far are you from the base of the tower? So where would that be? Exactly. That obviously is not how far you are from the top of the tower. That is not how high the tower is. That's just how far this one is. So go ahead and put 4.5 meters. Meters? Yes, meters. All right, awesome. Okay, now what do I do? The usual work. Label. Where's my hypotenuse? It's that dashed line. So hype. Where is my opposite to the 87? Which, as usual, I'm going to circle. Where's my opposite? Is it the ground or the tower itself? The tower itself, which is exactly what we're trying to find. Nice. So OPP. And this one will be ADJ. Do we know the hypotenuse? Do we even need to find the hypotenuse? By the way, in so many problems, the hypotenuse is neither given nor what? Nor needed. What do I know? What am I trying to find? Good. So what do we say? We relate opposite and adjacent. We relate OPP and ADJ. Which one of the three trig ratios, the only one that definitely relates only op and edge? Which one? I heard 10. So, ka, so, toa. T-O-A. 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 I think, yes, so recording, good. So we use 10. We use 10. Okay, what do we do then? The same procedure. 10 of what angle? What's the only angle no, I can't, by the way, you're right, 87. I don't want to say what's the only angle I know. Because I know 87, I also know this one. Can someone guess how big this one is? How much? 3. Because 87 plus 3 is 90, plus another 90 is 180. Obviously, it's not, it doesn't look like 3. It's much bigger than 3. That's because my diagram is rough. Okay, so 10 of 87 degrees. Please remember to always put degrees. Don't just put 87. Equals up over edge. Okay, how much is 1087? I don't know. That's what we have calculators for. Clear. 87. Trig. Do not put second. You know it. You just want to find the 10 of it. Oh, my bad. I pressed sign by mistake. Sorry. 87. Trig. 10. All right. Whoa. Okay. I need to use 4 numbers after the decimal. Would this stay as 1, 1 or become 1, 2? 1, 1. There's a 3. It doesn't do anything. Oh, no, no, no. In my final answer. In my final answer, not my intermediate steps, always use 4 decimal digits. So 190811. 190811 equals. Which one do I want to find? Which one do I know? Think. Great, perfect. So adjacent becomes 4.5. And OPP just stays as OPP. Perfect. I put my best friend, the 1. And I can now see it's a criss cross. All right. So OPP times 1, which is just OPP, equals 4.5 times 19.0811. By the way, it's not going to be a super high tower. Okay. It's not like, at the height of the CN Tower, which is like close to a half kilometer. No, no, no. This is a small tower, like maybe downtown London or something. 4.5 times 19.0811. Okay. What's the rounding situation? To how many decimal places? 2. All right, so I have to stop here. Would this stay as 6 or go up to 7? Perfect. So the height of this tower, ladies and gentlemen, is 85.86 meters. 85.86